AI feels weightless. You type a question, an answer appears, a sentence, an image, a line of code, a video, a plan. It feels like software. But behind that lightness is something extremely heavy. Land, power, cooling, chips, debt, construction, capital, heat. Every prompt travels through a physical machine. And that machine is growing. So the real question is not just, how smart will AI become? The deeper question is, what are AI data centers really building? Every industrial revolution has a place where the future is made. In the industrial age, it was the factory. Steel, coal, machines, labor, and capital came together inside one physical space. Raw material went in, products came out. In the internet age, it was the server room. Websites, search engines, social networks, and cloud software needed a place to live. Data went in, services came out. But in the AI age, something different is being built. Not just a server room, not just cloud storage, not just a warehouse full of computers. AI data centers are becoming factories for intelligence. Electricity goes in, chips heat up, models run, tokens are produced. Software begins to think, write, see, speak, plan, code, summarize, generate, and act. This is why the AI data center story is bigger than real estate. It is bigger than electricity demand. It is bigger than NVIDIA GPUs. The deeper question is, what are these AI data centers really building? And the answer may be, they are building the physical layer of machine intelligence. They are building a new industrial system. They are building the place where future labor, future software, future media, future science, and future automation may be produced. That sounds abstract. So let's make it physical. An AI data center begins with land, a location, a site close enough to power, fiber, water, permits, customers, and transmission lines. This already makes it different from normal software. An app can be launched anywhere. But an AI factory needs a body. It needs land, then it needs power. Not symbolic power, literal electricity. The kind that must be generated, transmitted, stabilized, priced, and delivered. Without power, there is no intelligence. The model does not think. The agent does not act. The video does not render. The chatbot does not answer. So before AI is a software story, it is an energy story. Then comes cooling. Because intelligence produces heat. Every answer, every generated image, every model training run, every inference request becomes heat inside a physical machine. This is one of the strangest truths of the AI age. Thought becomes thermal. The more intelligence we ask machines to produce, the more heat we must remove from the system. So, AI data centers are not just computing facilities. They are heat management machines. They need liquid cooling, airflow, pumps, pipes, chillers, backup systems, and increasingly specialized architecture. Then come the chips, GPUs, accelerators, memory, networking, storage, racks, cables, switches, power distribution systems. A modern AI data center is not simply a room full of servers. It is a tightly connected machine. The chips must talk to each other quickly. The memory must feed the compute. The network must move data with low latency. The power system must handle huge loads. The cooling system must remove heat without slowing everything down. This is why AI infrastructure is so expensive. Because the data center is not just holding computers. It is trying to turn thousands or hundreds of thousands of chips into one coordinated thinking machine. And once that machine exists, the question becomes, what does it produce? A traditional factory produces goods. A data center in the cloud era produced software services. But an AI data center produces capacity for intelligence. That capacity can become many different things. It can become a chatbot answer, a code suggestion, a generated video, a customer service agent, a drug discovery simulation, a financial risk model, a robot instruction, a marketing campaign, a personal assistant, a legal draft, a research summary, a piece of synthetic media, a workflow that once required a human team. This is why AI data centers are so difficult to value. They are not building one product. They are building optionality. They are building the capacity to serve many future use cases that may not fully exist yet. That is both the beauty and the danger. Because when you build a car factory, you usually know what car you are making. When you build a hotel, you know what room you are selling. When you build a shopping mall, you know the type of rent you need. But when you build an AI data center, you are building capacity before the final shape of demand is fully known. You are saying, we believe the world will consume more intelligence. We believe enterprises will automate more work. We believe users will ask more prompts. We believe agents will run in the background. We believe video, robotics, science, search, coding, healthcare, finance, education, and enterprise software will all need more compute. So the data center becomes a bet, a very large, very physical, very capital-intensive bet on future intelligence consumption. This is why the market is paying so much attention to hyperscaler capex. Microsoft, Amazon, Google, Meta, Oracle, CoreWeave, and others are not just buying chips. They are buying future capacity. They are buying the right to serve AI demand before everyone else can. They are buying land, power access, cooling systems, fiber connections, GPUs, memory, networking, and engineering talent. But more importantly, they are buying time. Because in the AI infrastructure race, time matters. A model can improve quickly, software can ship quickly, but power plants, transmission lines, substations, data centers, and permits do not move at software speed. This creates a strange mismatch. AI demand can appear almost overnight. A new model launches. A new agent product gains traction. A new video generator goes viral. An enterprise signs a huge AI contract. Suddenly, more compute is needed. But the physical infrastructure may take years to build. This is why power has become one of the most important constraints in AI. For years, the software industry acted as if the digital world was weightless. Move fast, scale instantly, deploy globally. But AI brings the internet back into the physical world. It needs electricity. It needs cooling. It needs construction. It needs transformers. It needs transmission capacity. It needs local communities to accept enormous buildings that consume power and water. It needs capital markets to keep funding the build-out. This is the part of AI that feels least magical but may matter the most. The AI race is not only about who has the best model. It is also about who can secure the power, who can build the data centers, who can finance them, who can connect them to the grid, who can keep the chips cool, who can get enough memory, who can make the economics work. This changes the map of the AI economy. The scarce asset may not always be the algorithm. It may be the site with power, the substation, the long-term electricity contract, the data center campus, the cooling technology, the supply chain, the ability to deploy compute faster than competitors. In other words, AI data centers are not just buildings. They are strategic territory. They are like ports in the age of global trade, like railroads in the industrial age, like oil fields in the energy age, like cloud regions in the software age. They are places where future economic activity may flow through. This is why the biggest companies are spending so aggressively. They are not only trying to meet today's demand. They are trying to own the bottleneck before it becomes obvious to everyone else. But this is also where the risk begins. Because infrastructure booms are always seductive. They create beautiful numbers, more data centers, more chips, more electricity contracts, more construction, more capex, more revenue for suppliers. In the short term, the build-out itself creates growth. NVIDIA sells more chips. Memory companies sell more HBM. Utilities see more demand. Construction companies get more work. Cooling suppliers get more orders. Real estate operators lease more capacity. Cloud companies announce more AI infrastructure. The whole chain looks alive. But the deeper question is not whether infrastructure can be built. The deeper question is whether the infrastructure can earn a return. Because capital expenditure is not the same as value creation. A data center is an asset, but it is also a liability if demand does not arrive. It has depreciation, power costs, maintenance, financing costs, chip obsolescence, cooling costs, utilization risk. If the compute is used heavily by paying customers, it can become a powerful economic machine. But if the compute sits underused, or if token prices fall too quickly, or if enterprises do not adopt AI fast enough, then the same machine becomes stranded capital. This is the line between an industrial revolution and a bubble. An industrial revolution builds infrastructure that later unlocks productivity. Railroads were expensive, but they changed transportation. Electric grids were expensive, but they changed factories, homes, and cities. Cloud data centers were expensive, but they enabled scalable software, streaming, mobile apps, e-commerce, and the modern internet. AI data centers must do the same. They must turn capital into productivity. They must turn electricity into useful intelligence. They must turn tokens into revenue. They must turn automation into margin improvement. They must turn agents into measurable work. Otherwise, we are not building the future. We are just building expensive rooms full of depreciating chips. This is why I think the phrase data center is becoming too small. It makes the build-out sound passive, as if these buildings simply store data. But AI data centers do not just store. They produce, they transform, they generate, they infer, they simulate, they automate. They are closer to factories than libraries. And what they are building is not just intelligence in the abstract. They are building a new supply of cognitive labor. That is the deeper economic idea. For centuries, economic growth depended on human labor, physical capital, energy, and technology. Humans did the thinking, planning, writing, coding, designing, communicating, and managing. Machines helped with physical force. Computers helped with information processing. But AI begins to move into cognitive work itself. Not all of it. Not perfectly. Not instantly. But enough to matter. So when a company builds an AI data center, it may be building something more like a labor factory than a server farm. A place where software workers can be simulated, where customer service can be automated, where code can be generated, where research can be accelerated, where marketing can be personalized, where video can be produced, where agents can work continuously. This is why the stakes are so high. If AI data centers become productive, they may become some of the most important assets in the economy. Not because they are beautiful buildings, but because they may produce an input every company wants: intelligence on demand. And once intelligence becomes on demand, business changes. Small teams may do more. Software may become more autonomous. Media production may become cheaper. Scientific research may move faster. Robotics may improve. Customer service may become more automated. Enterprise software may become less like a dashboard and more like a workforce. But this future has to be proven. The market cannot live forever on the phrase AI will change everything. At some point, the infrastructure must show up in revenue, margins, productivity, and real customer demand. This is why investors should watch utilization. Not just CapEx, not just GPU orders, not just data center announcements, but utilization. Are the clusters being used? By whom? For what workloads? At what price? With what margins? Are customers paying for inference? Are enterprises renewing AI contracts? Are AI agents saving labor costs? Are cloud companies getting returns on invested capital? Are token prices falling because of efficiency or because of oversupply? Are model companies able to pay for the compute they consume? These are the questions that separate hype from infrastructure. Because real infrastructure becomes boring after it succeeds. Electricity became boring because it worked. Cloud computing became boring because every company began using it. AI data centers will only become truly powerful when they stop feeling futuristic and start becoming necessary. That is the destination. Not spectacle. Necessity. The moment when AI capacity becomes a normal business input. The moment when companies do not ask, should we use AI? They ask, how much intelligence do we need this quarter? The moment when compute becomes part of planning, budgeting, productivity, and strategy. That is what AI data centers are really trying to build. Not just more servers. Not just larger campuses. Not just impressive capital expenditure. They are building the possibility that intelligence becomes a utility. But there is one more layer. AI data centers are also building a new hierarchy of power. Because whoever controls scarce compute can shape access. Who gets the best models? Who gets the fastest inference? Who gets the lowest cost per token? Who gets priority when power is constrained? Who can train frontier models? Who can run millions of agents at once? Who can offer AI cheaply enough to capture users? Who can absorb losses long enough to win distribution? This is why the AI infrastructure race is also geopolitical. Countries care, companies care, investors care, energy markets care? Because compute is becoming strategic. The data center is no longer just a private business facility. It is becoming part of national competitiveness, industrial policy, energy planning, and economic security. This is why the AI age feels so strange. It is digital, but physical. It is software, but industrial. It is intelligence, but electricity. It is invisible to the user, but massive on the ground. A person types one prompt in a quiet room, but behind that prompt is land, power, cooling, chips, capital, and a global supply chain. That is the paradox. AI feels light, but its infrastructure is heavy, and that heaviness is what makes this investment cycle so important. Because when the world builds heavy infrastructure for a new invisible layer, something major is happening. The question is whether that invisible layer becomes as essential as electricity, cloud, and the internet. If yes, AI data centers may become the factory floor of the next economy. If no, some of them may become monuments to overconfidence. So when I look at AI data centers, I do not only see buildings. I see a bet on future demand, a bet on machine labor, a bet on intelligence becoming a daily input, a bet that businesses will keep replacing old workflows with AI-native systems, a bet that power, chips, cooling, and capital can be assembled fast enough to meet the world's appetite for intelligence. And that is why this topic matters. Because AI data centers are not really building data centers. They are building the physical body of the AI economy. They are building the place where electricity becomes cognition, where capital becomes compute, where compute becomes tokens, where tokens may become work, and where work may become value. The whole investment question comes down to one simple line. Can these machines turn intelligence into productivity? If they can, the AI data center build-out may become one of the defining infrastructure stories of our lifetime. If they cannot, the market will eventually remember that even the most beautiful machine is not valuable unless the world knows how to use what it produces. So the next time you hear that another AI data center is being built, do not imagine a warehouse full of servers. Imagine a new kind of factory. A factory that does not produce cars, steel, or oil. A factory that produces intelligence. And then ask the question that matters. Who will use it? Who will pay for it? And will it make the world more productive? For education and reflection only. Not financial advice.